picture should include all levels of society. Most low-income communities are left behind when it comes to innovation and growth. This study focuses on improving the living conditions of low-income communities in South Africa. Innovation and growth do not need to be expensive and focused on capital gain. Innovation must also focus on a long-term outcome and investment in local communities. This study focuses on developing a low-tech system to improve the living conditions of low-income communities and include these communities in the procurement of materials, manufacturing, and maintenance. Low-income households burn paraffin or coal within living spaces to generate heat. A research study published by the South African Department of Environmental Affairs has indicated that an estimate of 9,000 deaths are caused annually in South Africa due to indoor air pollution from non-renewable fuels. Therefore, it is essential to investigate, identify and develop an alternative indoor heating method. The study aims to improve the indoor comfort levels for low-income households by substituting non-renewable fuels and using natural resources. In order to substitute the use of non-renewable fuels, a cost-effective and energy-efficient system should be designed, tested and implemented. In order to improve the indoor temperature while allowing for ventilation, a solar heating system with heat storage capacity is developed by evaluating the existing studies on solar air heaters and heat storage material systems. The heating system will be constructed and tested to determine the effectiveness. Through the developing of a cost-effective solution, the proposed study will investigate the possibility of constructing the solar heating system from waste and off-cut materials. If solar heating can be implemented successfully, the aim is to substitute non-renewable fuels. The system will assist with internal ventilation and limit the spread of viruses or infections within enclosed spaces. The proposed heating system will transfer the external ambient air through the system and allow heated fresh air to enter the housing units without opening windows or doors during the winter season. According to a study published by the World Health Organization, it was found that the rate at which viruses and infections spread through enclosed and poorly ventilated rooms is much higher compared to ventilated spaces. It is anticipated that the proposed heating system can improve ventilation by replacing the internal air with fresh air. The study also focuses on creating jobs by using local labor with low-income communities. The construction of solar heating systems will require the skills of an electrician, plumber, and carpenter. The research document is based on the design of a low-tech solar heating system for residential use in Climate Zone 2 of South Africa. The outcomes and potential of the main study, conducted during the winter and summer season in July, August, and September 2021, will be discussed. The experiment is divided into two sections: solar heating during the winter season and ambient cooling during the summer season. Each section has two parts: enclosed ventilated heating and enclosed ventilated cooling. The ventilated heating system allows fresh ambient air to circulate through the system at all times. The ambient air circulated through the solar air heater reached a maximum of 43 degrees Celsius, which circulated through the rockbed heat collector. The results after the 7-day experiment indicated that the surface of the rocks was charged with the heat during the day. However, as soon as no solar energy was available, the ambient air cooled the surface of the rocks, and no solar energy was stored to use during the evening. The enclosed heating system was changed based on the results to prevent ambient air from entering the system, and conducted an experiment on an enclosed heating system. The enclosed heating system does not allow any fresh air through the system. It recirculates and reheats the solar air heater's heated air in the system. The air which was circulated through the system reached a maximum of 79 degrees Celsius. The anticipated outcome for the solar heating system is for the solar air heater to capture the solar energy and ventilate hot air through the rockbed heat collector. The solar energy will charge the rocks during the day and discharge heat during the evening. However, this was not the outcome. The initial results indicated that the system does not provide hot air at the outlet of the rock bed during the evening as anticipated. This led to further investigation of the results, and it was found that the energy must discharge somewhere else. When looking at the 7-day results of the enclosed system, it is noticed that the lowest temperature of the rockbed outlet increased each day. This is a result of the surface heat being discharged to the core of the rock, as the core of the rock is colder than the rock's surface and absorbs the heat. The core temperature will increase incrementally each day and discharge as soon as it reaches capacity. This is called the flywheel effect, where the thermal mass such as concrete, rock or water stores heat and discharges as soon as the thermal mass reaches capacity. The experiment was done over 7 days and showed the potential for seasonal charging. Seasonal charging will require the system to charge during the summer to reach capacity and maintain heat during the winter. During the heating experiment, the potential to use the heating system for cooling during the summer was recognized, as the system will be redundant for approximately 7 to 8 months. During the cooling experiment, the solar air heater panel is covered to limit the solar exposure and use the ambient air during the night to discharge the rocks. The enclosed and ventilated cooling experiment was conducted over 3 days during the summer season in September 2021. The ventilated cooling system recirculated 50% of the air through the system and 50% fresh ambient air. The system recirculates the air by connecting one of the solar air heater's inlets with one of the rock bed's outlets. The remainder of the solar air heater's inlet and the outlet of the rock bed remain open to circulate fresh air. The system was running for 24 hours per day without any intervention. The result from the experiment proved to provide cool air at an average of 28% lower than the ambient air at the peak temperature during the day. The system provided cool air during the daytime. The rocks discharged during the evening and provided warmer air than the ambient air temperature. The enclosed cooling system recirculates air through the system during the day. The control valve at the intake of the solar air heater and the outlet of the rock bed is open to allow fresh ambient air during the evening to discharge the rocks. The intake and the outlet of the system are closed during the day. The results from the experiments provided cool air at the average of 18% lower than the ambient air at peak temperature during the day. The system provided cool air during the daytime. The rocks discharged during the evening and provided warmer air than the ambient air temperature. The enclosed heating system performed better than the ventilated heating system. However, it did not provide fresh air as it is enclosed and will require seasonal charging to perform at its optimum. The ventilated cooling system performed better than the enclosed cooling system. The system also provided fresh air at the outlet of the rock bed and did not require any interventions. All materials used to construct the solar heating system are from off-cut, redundant construction material or waste. The only items bought are the circulation fan and the solar panel. The solar heating system can be applied to existing and newly built buildings. When applying the solar air heater system to an existing building, the solar air heater can be fixed to the northern facade, with the rock bed constructed next to the building. When applying the solar air heating system to a newly built building, the solar air heater will be fixed to the northern facade, with the rock bed constructed underneath the floor slab. It is proposed that the solar air heater is fixed on a hinge to change its angle between summer and winter season. The system focuses on the thermal comfort of low-income communities and creates a new ecosystem within these communities. The construction of the system will require the skills of a plumber, carpenter, and electrician. Therefore, it will create job opportunities for the construction and retail sectors. The procurement and selling of the materials required to construct the system will create a new ecosystem. It will create opportunities for collecting the material, sorting stations, and reselling the material for construction. Thank you for the opportunity to present my work.